Let's say we have a random variable x, which can take any value between 0 and 10. When an event occurs according to the probability distribution of x, we refer to this as sampling from x. Here is what we call the probability density function of x, which basically tells us the probability of a sample being any of the values between 0 and 10. We usually note p of x, the density of x. An interesting quantity describing the distribution of x is its expectation, usually noted e of x. It is basically the average value that you can expect when sampling from x, and it can be computed using the integral of the probability density function. Now let's consider two random variables, x and z. What you see here in 3D is what we call the joint probability distribution of x and z. This represents the probability of each possible pair of events occurring together. Of course, each variable also has its own individual probability distribution, known as the marginal distribution. As before, we denote the marginal distribution of x as p of x and the marginal distribution of z as p of z. An interesting property of the joint distribution is that we can use it to compute each of the marginal distributions. For example, to find the probability of sampling a specific value according to x, we integrate the joint distribution over all possible values of z,